In this video, we'll look at the secondary structures of your immunoglobulin-like domain 3 over here from your fibroblast growth factor receptor 2. This structure looks a little different to the blob that I showed you last video because this is showing all the little structures that make up the blob that we know as the whole protein. Starting off, you'll see three different colors that form three different shapes. If you look at this red one over here, this structure is called an alpha helices, and you'll notice about 11 of them all throughout this immunoglobulin-like 3 domain. These are called helices because they sort of look like ribbons that are coiled. Next, you'll see these yellow sheet type things, and these are called beta strands. These form 6 beta barrels. So you have one over here, 2, 3, 4, 5, and 6. And these beta barrels are sort of like pockets or grooves, which is really important for your fibroblast growth factor receptor immunoglobulin-like 3 domains, because each of the 2 protein arms of the receptor have 3 immunoglobulin-like domains. So you have 3 on this side and 3 on that side. And these immunoglobulin-like domain grooves are pictured as these beta sheet barrels. Finally, you'll see these coily, wiry, green type structures. And these are just what we call random coils because they form all over this structure and they join the whole thing together. If we now look at the pink structures over here, start again. These pink structures over here are really important for our variant, especially this. When we have a variant C278F, what happens is that 278th codon, which is this little pink bit on this green wiry strand, that gets changed into phenylalanine. So this is usually a cysteine, and this cysteine joins to this cysteine on this beta sheet over here, and this is your cysteine at the all right. When your C278F variant occurs, it changes the cysteine at position 278 and changes it to phenylalanine. So the cysteine that gets changed is actually here, and it's displayed as the pink bit in this green wiry strand. The cysteine is important because it joins to this cysteine on this yellow sheet over here, and this is your 342 codon. This is your 342nd codon. And these two cysteines, because they're so close together, they form this bridge. And all right, now let's look at what happens when we have no. All right, when we have the C278F variant, this cysteine at position 278, so over here you can see this, no. All right, when we have the variant, no. When we have the variant 278F, cysteine over here that's highlighted in pink on this green strand, it's changed to a phenylalanine. And this ends up hurting this bond between this phenylalanine. And this causes a bit of problem to this immunoglobulin-like domain, immunoglobulin-like groove over here. And we'll see why in a second. What can I say? All right. When we have a variant 287F, it affects this cysteine at position 278 on this green wire over here. And this bit is highlighted now. All right. Variant 278F affects the cysteine codon at 207. All right. The variant 278F ends up changing the cysteine at codon 278, and you can see that highlighted here in pink on this green strand. And this ends up hurting the relationship with this green strand that I just showed you and this region of this yellow sheet that's colored in pink. And this region in pink on the yellow sheet is your 342nd codon. This is also a cysteine. So normally these two cysteines form a structure that looks a bit like this. All right. When the no, no, the cysteine at 278 and the cysteine at 342 form this bridge over here that we know as this disulfide bridge. And this is really important for the immunoglobulin-like domains to function normally. When the variant occurs, this bridge is broken, and this is what contributes to Crouzon syndrome.